So let's go ahead and begin by going over our content and our language objectives. Okay, so the learner will be able to develop and use a formula to determine the volume of a rectangular prism. Here's your language objective. I can explain how to determine the volume of a rectangular prism to a partner. Okay? So here's the problem that I have here. I have a box, and I want to know how many cubes would fit into this box right here. But I don't want to count. So how many cubes do you think will fit in here? So in the cubes that we're talking about are 1 square inch, which means that when I measured the length, the width, and the height, each of them is 1 inch. So how many of these 1 inch cubes do you think will fit in here? Turn and tell a neighbor. Oh, I'm hearing 150, 50. Raise your hand here. What do you think, Anthony? You think, well, but how many do you think this is? So how many do you think it would take? Maybe I don't have enough. 150? Landon? About 200? Okay, well we're going to find out today. We're actually going to find out the answer for how many cubes it's going to take to fit in there, but we're not actually going to count them. So that's what our plan is today. Now when we're talking about how many will fit inside, what we're really talking about is volume. Now raise your hand if you've heard that word before. Now we're not talking about the volume as in how loud something is, but this kind of volume for how much, and if we look at the definition here, it's the amount of space occupied by an object or enclosed in a container. So it's how much stuff will fit inside here. We call that volume. Okay? We measure it in cubic units or cubes. Now the size of the cube will vary depending upon if you're measuring in inches or centimeters or even yards. But we measure them in cubic units or cubes. So today we're just going to kind of focus on inch cubes. So a 1 inch by 1 inch by 1 inch cube. And we're going to kind of figure out how many cubes will fit inside. What we're figuring out is volume. Now, there's a formula that you use to figure out the volume. But I have a challenge for you. I think you guys can actually just do it yourself. You don't need to look up the formula. You guys are going to be mathematicians and discover the formula. So what I'm going to do is I'm actually going to give you a shape, okay? And I'm actually going to tell you its volume. You have to figure out how it's calculated. So you have to come up with the actual equation or formula, okay? So we're going to look at how could I figure out the formula or the area, the volume of this shape without actually putting cubes inside, okay? So you're going to work in teams, and it's going to be your tables. You're going to work in teams, and what you're going to do is I'm going to give you a sheet of paper, looks like this here. And it actually already has the volume of the shape up on here. Okay, so like this one's 60, this one's 30 cubes. You have to figure out how you could, without actually counting them, calculate it. Okay, so you're going to derive a formula for figuring out volume. Think you can do it?
Yes.
All right, so I'm going to give you some parameters here. So you're going to calculate the volume without actually counting them. So some things to consider. I mean, anytime you problem solve, what you want to do is use what you know to solve what you don't know. So in this situation, what do we already know? We know how to measure just one-dimensional, right? Linear. We know how to figure out the area. So what we're going to use is our knowledge of area to help us figure out our volume. Okay? We're going to use calculators, okay? Because we're not focusing on the computation, okay? We're going to focus on the critical thinking and reasoning, okay? So we're going to flexibly use what we know about our two-dimensional shapes and our three-dimensional shapes and what we know about area to help us figure out what that formula is for volume, okay? So here's the deal. Everyone is responsible. So when I'm walking around, I don't want to see one person dominating. I want respectful conversations, respectful discussions, okay? And the key thing is if you don't know where to start, try something. Have an idea, just try something, and at worst, it tells you what doesn't work. And that might lead you to what does work. Okay, so my only parameter is that you try, everyone participates, you try something, because that's going to point you in the direction of the right answer. I'll get your question in just a second here, Katie. All right, now, when your group thinks they have the answer, don't just blurt it out, okay, because we don't want to rob other groups from that opportunity. But I want you to just raise your hand, and I'll kind of say yay or nay. Yep, you got it. No, you didn't. But maybe you're in the right direction. So we're going to take about 10 minutes here, and you guys are going to get in a group, your table, and you guys are going to just hash this out. I'll give you calculators and that sheet there, and you're just going to kind of problem solve, flexibly think, just try and figure out what could work. And see if you can figure out how you determine the volume of a container. Okay? And the key thing here is use what you know about area. Cassie?
Are we going to do all of them on paper?
You don't have to. These are just the examples that are on here. You don't have to use all of them. If you feel like you got it figured out on that first one, then great. But typically, just because it works with one, you might actually come up with the wrong idea, but it does work for this. So then you try that idea on this one, and maybe it doesn't work then. Sometimes you can actually have an idea that works for one, but remember, it's got to not just work for one, it's got to work for all of them. So you're going to derive a formula for calculating the volume of a rectangular prism, and we're going to use that backwards design where here's the answer. You have to kind of come up with essentially the question. How do you calculate and come up with this without counting? Okay?
4 times 5 times 3.
We're trying to figure out the formula, not the answer.
Oh, then I need
What I think it is because it's basically area but multiple times. So just try to figure out this. 1, 2, 3, 4, 5, 6. So 6 divided by 3 is 3. So 3 times 3 would be 6. How do you figure that out? Length times width.
3 times 3 is not 6, it's 9.
4, 5. 5.
You said that's real, so stop. Could do 3 times 3 is not 6, it's 9.
Or it could be all of them on the top. All of them on the top. Times all outside.
We think it's 12 times 5 equals
3 times 4
Okay, how did you come up with the 12? Remember, what does the 12 represent? What does the 5 represent? So don't use our numbers though. What do those numbers represent? You don't have to raise your hand here. You guys have a discussion. Don't talk to me, talk to each other.
how many cubes are in a layer of this stack? And it's on the sides times 5. Yeah, on the layers on the sides.
So what do you think the formula is? So remember, you're gonna come up with a formula that I could use over and over again.
Length times width got us number 8, so 2 times
So we need to find a formula that all the cubes on the top and all the cubes on the edge.
All right, so I heard some really good discussions, but I want to clarify a couple things before you continue on. Okay, first thing is, we said we want to use what we know about the area of a rectangle and about that formula to help us solve what we don't know, which is the formula for volume. You got to come up with that formula for figuring out the volume. So what do we know about the formula of a rectangle? Okay, the formula for figuring area of a rectangle. Turn and tell your neighbor. What do you know about the formula for area of a rectangle? All right, Jalen. What is the area, or the formula for the area of a rectangle? How do I calculate the area of a rectangle without actually counting the squares? What's my formula?
length times width.
Width, yep. So we're going to use that to help us out. Okay? So the formula for area of a rectangle, area equals length times width. Okay? Use that knowledge to help you figure out how to calculate the volume. Let's think about the difference between a square, which is when we use area, and a rectangular prism. What's the difference between the two? Okay. So we really need to be thinking about what's the difference between a square and a rectangular prism or cube, and then what's my formula for area and how does that relate to figuring out the volume of a cube? Remember, volume is how much stuff can fit inside or how much space it takes up. Okay? So go ahead and have some more discussions with your group. See if you can utilize what you know about area and that formula of area to come up with a formula for volume. Okay?
We're thinking length times width times length times width plus 1 inch.
Plus 1 inch. Okay. Why? So is it always 1 inch?
No. It could be more than 1 inch. If it was like a bigger thing. Because you can measure the box of that and then since you have 1 inch cubes, you could use the cubes to see how the box, how many the box could fit.
Well, so here, if I do length times width and add 1, do I get 60?
No.
Okay, so then that won't work, but at least you know, right? You're on the right track. So we want to know what formula can I use that will always get me to the correct volume. I plug in my information, but what's my formula for figuring out volumes?
I think we found the formula.
Okay, let's hear it.
That you have length times width, and then you have like.
Well, that's area. Okay. Okay.
So then you multiply it by these.
By that, what is that?
That's the amount, the height.
The height. So what's the formula? Let's clarify.
It's length times width times the height.
Height. Okay. So tell us how you came to your answer. So how did you figure out what the formula was?
We did length times width, and that didn't equal 30. So we did it times height, and that equaled 30.
For my box, what would I need to do to figure out its volume? Or to tell your neighbor. If I wanted to know how many cubic inches would fit inside this box. Raphael? I just say that?
No, you do it.
How do I do length times width times? I need to first measure it. So I need to measure my length, my width, and my height. Okay, so first thing I got to do is actually measure it. So I measured that already, and I have that. Okay. So when we measured it, so the length is 13, the width is 9 inches, and the height is 7 inches. So now what do I do with that information? Mackenzie, what do I do with those numbers? What do I do with my length, my width, and my height here?
Once you times them all, and that's the answer you get. If it's not, is your volume?
Yep, so volume is going to be my length multiplied times my width multiplied times my height. So you agree with him?
Yeah, I do.
All right, what's another idea, Landon?
You do 9 times 7.
Okay, 9 times 7. What's that?
Then you
Well, what's 9 times 7?
63.
63. Okay, so now I'm going to take 63 times 13. Boy, that's a tough problem. So what can I do now?
You can take 63 times 10 and then take the answer from that times 3.
Take that times 3. The answer that I get here? Well, no, we took 63 and what you got here, we're going to take it times 13, right? So 63 times 13. And what did we do? We broke 13 into 10 and 3. So we need to do 63 times 10, but we're a little mixed up on the last step.
For the bottom one, you can do 6 times 10, and then it'll equal 60. Then you add a 0. Then you do
Well, this one times 10, what do we do when we just multiply times 10?
Just add a 0.
Just add a 0. So 63 with a 0 is 630. However, so I've taken my 13, I took 63 times 10, what's left? 63 times 3.
Oh no.
Well, what's 60 times 3?
180.
180. 3 times 3. 9. So 180 plus 9 is 189. Okay. So then add these up. What's 630 plus 100? 730, right? Plus 80. 730 plus 80.
800.
810 plus 9 more makes 819. Let's see if we were right.
Yay!
You were. Good job. So you did a pretty complex problem there over your head. So the volume is length times width times height. 13 times 9 times 7. And it's 819 cubic inches. That means that I could fit, remember how you guessed earlier? I think the highest guess was 150. The actual answer is 819 cubes would fit inside here.
Awesome!
We're going to give you your practice here in just a minute, but what I want you to do is reflect here. Our objective today was to develop and use a formula to determine the volume of a rectangular prism. The language objective, I can explain how to determine the volume of a rectangular prism to a partner. On a scale of 1 to 4, 1 being, yeah, I really don't understand this, and 4 being, I am a mathematical wizard when it comes to determining volume.
About 3.
What are you right now? Okay. Can you explain to a partner, can you tell somebody how to determine the volume of a rectangular prism? All right, on the count of 3, show me. 1, just right in front of your chest here. 1, 2, 3.
Oh, so we can do.
Thank you for doing so without talking. All right. So we'll continue to practice this. This is just the introduction here. But we'll continue to practice working with volume. Okay? You'll have for homework tonight a chance to practice determining the volume using that formula of length times width times height.